differentiate. So we got a function to differentiate, ln natural log of x times e raised to 9x. So this problem can be done in two different ways, because using a property of logarithm we can expand, or we can simply use the chain rule without using the property of natural log. So let me do the easiest way, not the easiest, maybe easier if you know how to expand this natural log. As we know, natural log of product, when you have a natural log of product, u times v, let's say, natural log of u times v, if you expand it becomes natural log of u plus natural log of v. And we know that natural log of e raised to something is just that comes to the front, and natural log of e is 1. So I'm going to use this property to simplify, then the derivative will be just quick. Okay, let's see. So using property of natural log, this is natural log of x plus natural log of e raised to negative 9x. This is natural log of x plus this factors to the front, so that's negative 9x, plus negative 9x means just minus 9x, times ln of e is 1. So this expression, this function simplifies to ln x minus 9x. Then we can take the derivative, which becomes derivative of ln x is 1 over x. This is minus 9x. Derivative of minus 9x, minus derivative of 9x is just 9. So the answer is 1 over x minus 9. But this can be done, we can find the derivative without using this natural property of natural log, okay, which is, we can think the whole expression as natural log of some function. So in this case we need to use the chain rule, and we know that when we have natural log of u, its derivative is 1 over u times u prime. And if we have a product, let's say u times v, that's u prime v plus v prime u. And we also know natural log of e raised to something is just that thing. This comes to the front, and ln of e is 1. So here this is, so I'm using alternative way. Either way we need to get the same answer when we simplify fully, okay. Natural log of e, sorry, natural log of u. Then when we use this formula, so derivative is then 1 over u, which is x e raised to negative 9x, times derivative of this u, which is x times e raised to negative 9x. Okay, so this derivative means we got a product. So we must use the product rule to find the derivative here. Okay, it's like u times v. We have 1 over x times e raised to 9x here, using the product rule that I wrote here. Derivative of x is 1, no need to write, e raised to negative 9x, plus derivative of e raised to negative 9x. So that's another chain rule. So when we have e raised to some function, not minus, could be minus, doesn't matter, okay, and when we find its derivative, it's always itself times derivative of u. So when we take derivative of this second factor, which is e raised to negative 9x, derivative of v is itself times derivative of 9x, which happens to be negative 9. That's v prime u. U is x. Okay. So I use the product rule here, and this is it. I mean, but they do not look same, because this is 1 over x minus 9. It looks giant, but we can simplify and it will be the same, 1 over x minus 9. So let me erase a couple of things here, make room to simplify. Okay, here is 1 over x times e raised to negative 9x. If you look at closely, this is times means one term, another term, two terms. From these two terms, we can factor e raised to negative 9x out. That means in the first, everything is out, so this is 1. This is negative 9x, and this one is out, so pretty much minus 9x. Okay, this plus and negative means minus 9x. And now, if you look at it closely, when we factor something out, this is times, so these two cancel. Okay, then what is left? 1 over x times quantity 1 minus 9x. Now we can simplify further just to match with this answer. I mean, these steps are not needed, just to make sure. 1 over x times 1, when we distribute, 1 over x times 1 is 1 over x, minus 1 over x times 9x. 1 over x times 9x means x cancel, 9. So we have the same answer. Okay, so in this case we use chain rule, and looks a lot of work, but we didn't have to use any natural log property. That's why we learn how to use natural log to find the derivative. When we use natural log, properties of natural log, then some derivatives could be quick, like this final.